And again, it's not a mandate, it's never a mandate, but it's a recommendation because it works more effectively. Okay? So one last reminder, can you guys keep your video on? Unless you think it'll look awkward. Yes, I am.
Sir, I'm at a friend's house right now.
Okay, that's fine, that's okay. Okay, is everybody with me so far? We are going to learn about, hello Sundara. So today we are going to learn about a new concept called Polynomial Remainder Theorem. Polynomial Remainder Theorem. And let's see if anybody has heard about it before. Anybody? Sana, Disali, Vasundhara, Riyahi, Sanvita, anybody?
What was it?
It's called Polynomial Remainder Theorem. Any luck with this interesting name or interesting concept?
I
Vasundhara,
heard
Ram.
what polynomials were, but I don't know about polynomials here.
Okay, so this next 10 minutes, I can promise you guys, not next 10 minutes, this whole class is going to be one of the magical class, okay? Because we are learning some magic trick in the class today. Now let's look at what this magic trick is all about. So we are going to learn about polynomial remainder theorem. What it says is, if you have function of x equals some polynomial, okay? Some, any polynomial, okay? Let's say x to the power 4 plus x to the power 3 minus 2x plus 18, okay? I just made it up. I have a function which equals to this polynomial. Does it sound okay so far? Yeah? So function of x is equal to this. Meaning if you want to evaluate x for any value 1, 2, 3, 4, 5, 6, what you will do is in every place where you have x, you will replace it with that value, right? Let's say if you are evaluating this for x equal to 5, you will replace every x with 5 and you will evaluate this, correct? So far everybody okay? This is how you evaluate a function, find the value of x. So this polynomial remainder theorem says that if you have a polynomial function whose value is equal to this polynomial, then function of x minus a, okay, will have a remainder of if you divide the function of x by function of x minus a, then you will have a remainder of f of a. Now it sounds very cryptic, right? Let's look at it in a very simple way. So polynomial remainder theorem says that if you have a polynomial, let's say f of x equal to, let's start with something simple, x squared plus 4x minus 9, okay? If you divide that by x minus a, if you divide this by x minus a, then your remainder will be equal to f of a. And again, this is still looking cryptic. So let's put some x value as, let's say 2, okay? So as per the polynomial theorem, it says if you divide f of x, meaning x squared plus 4x minus 9 by x minus a. So let's say here a is equal to 4. Okay. So if you divide the polynomial with x minus a, then the remainder, whatever, once you do the long division, whatever is the remainder, that will be equal to f of 4. This is a. So now let's read it again. If you have a polynomial, if you divide that polynomial by x minus a, where x could be any value 1 to any number. If you divide the polynomial by x minus a, your remainder will be equal to f of a. So now here we are putting a equals 4. So what will be f of 4? Let's first find it out. F of 4 will be equal to, we'll put 4 in this whole function. So 4 squared 16 plus 4 times 4. 16 plus 4 times 4 minus 9. 16 plus 16, 32 minus 9, 23. Okay? F of a, f of 4 is 23. Okay? Now this one says, if you divide this polynomial by x minus a, where a is your 4 here, then the remainder, you are predicting what will be the remainder of this long division. And that will be equal to this value, 23. And we'll check that. Are you guys with me so far, or I'm making it complicated? Bhavish, is it making sense, better? Ipsa? I'm reading this. Dishali, Anika, everybody okay? Sana? Okay, I'm repeating this. So the polynomial theorem says that if you have a polynomial as a function, and you divide that polynomial by x minus a, where a could be any number. If you divide this polynomial by this, your remainder will be equal to value of f of a. So here we are trying to divide by x minus, we are trying to divide this polynomial x squared minus 4x plus minus 9 by x minus 4. When we divide that, it says, when you do the long division here, your remainder would be equal to f of a. And we just check. My a is 4 here. F of 4 we got as 23. Let's check if this polynomial remainder theorem is to be believed. Are you guys ready for experiencing this? Desali, Anika, Sanvita, yeah, everybody okay, right? Okay, now let's do that long division. If I had to divide this thing by x minus 4, so as we learned in the last class, our first goal is to go in order so that we keep knocking off the highest power of the variable. So what we can do is multiply this by x, so that gives me x squared minus 4x. Okay? Now let's subtract. So this minus becomes plus. So these two gets nullified. This became 4x plus 4x is 8x. And then minus 9. Now, what is the number that I can multiply this whole thing by to get a 8x? Obviously 8. So we'll multiply this by 8. So this became 8x minus 8 4 ja 32. Now let's subtract. So minus, this becomes plus. 9 minus 9, 32 plus. Was this sounding magical? No, not yet. So see, if you go by what this polynomial remainder theorem says, we just saw an application of it. It said that if you have a polynomial in terms of x, and if you divide that by x minus a, where a could be any constant, when you divide by that x minus a, then your remainder will be equal to f of a. So first thing we did, okay, what is f of a? This is my function. Let's evaluate for a equal to 4, and then we'll divide this polynomial by x minus 4. So we put a equals 4. So first we found f of a, which was 23. So we were saying that when I divide this polynomial by x minus a, which is 4 here, my remainder will be 23. And without doing this long division, we could predict this. Now let's look at one more example. Did you guys see what this polynomial remainder theorem says, or you guys still trying to figure it out? Sana, is it clear, beta? I'm just randomly calling out one name. Sana, Vasundhara, Samita, okay? Ipsa, okay? Bhavish, okay? So again, I have a very good habit of making a problem on the fly. Okay? I mean, be good or bad. Let's cook up a problem. Okay, I'm saying I have a polynomial f of x equals x to the power 5 plus 3x cube plus 15. Okay? And polynomial remainder theorem says that if I divide that by x minus, let's say 8, that means my a is equal to 8. Polynomial remainder theorem says that if you divide this polynomial by x minus 8, then the remainder would be equal to f of a, or here it is 8. So let's evaluate this for x equal to 8. So 8 to the power 5 plus 3 into 8 cube plus 15. Let's see how much it turns out to be. 8 to the power 5. Okay. Let's keep 8 cube here. 8 square plus 3 plus 15. 8 cube is 8 is 64 times 8. 8 4 is 32. 8 6 is 50. 8 6 is 48 plus 3 51. 512 into, this is 64 plus 3 67 plus 15. So 512 into 67, 7 2 is 14, 7 is 7 plus 1 8, 7 8 7 5 is 35, 6 2 is 12, 6 1 is 6 plus 1 7, 6 5 is 30, 4 0 3 4 3 plus 15. So this is 4 plus 5 9, 1 3 3 4. Okay. I'm going back to my childhood days. So now as per the polynomial remainder theorem, if I had this polynomial, if I tried dividing that by x minus 8, where 8 is my a, okay, then polynomial remainder theorem says that if you divide this by x minus a, your remainder would be equal to f of a, which is a is 8 here, because I am dividing by 8 minus x minus 8. So whatever you are subtracting from x, that is your value of a. So for a equal to 8, we evaluated that, which got us 34319. And I'm not sure if I made some mistake with this calculation. This is not important right now, but the polynomial remainder theorem says that assuming this calculation was right, if you divide this polynomial by x minus 8, then the remainder will be equal to f of 8. So whatever you are subtracting from x, evaluate that function for the value of, for that value, and that would be your remainder. Does that sound okay? Or you guys want to pick up something little easier so that it's easy to validate the beginning. Let's not overwhelm ourselves with lot complicated problem. Let's pick up something which is easy to calculate. Let's say f of x equals 3x cube plus 5x minus 17. Okay, I just made it up. Little lighter so that our calculation is easier and is easy to relate. Are you guys with me so far? Samrita, Vasundhara, Nika, everybody okay? I'm hoping everybody is okay. So the polynomial remainder theorem says that if you divide this polynomial by, let's say, x minus 3, then your remainder will be equal to f of 3, because that is what you are subtracting from x. So if I divide this polynomial by x minus 3, then my remainder would be equal to f of 3. So let's see what is f of 3 here. F of 3 will be 3 into 3 cube plus 5 into 3 minus 17. So this became 3 cube is 27 into 381 plus 15 minus 17. So it will be 79. Okay. So when I divide this thing by x minus 3, I should get a remainder of 79. Let's see if that is the case. Yeah? We are still validating this polynomial remainder theorem to see if this is correct or not. Disali, is that okay, Beta?
Yes, sir.
Okay, let's do that. So what we'll do is, we'll do the kids play that we learned in the previous class, polynomial long division. So we are not doing anything fancy. We are just trying to divide this by x minus 3. That is our goal. So how do we get rid of the first highest value of x? I have x here. So I'll multiply it by 3x squared. So that is 3x squared into x will help me knock out the first term. So first thing is 3x squared. So if I'm multiplying 3x squared by this, I get 3x cube minus 3 is 9x squared. Okay, now let's subtract. Okay, so these two will get knocked off, but here I have 9x squared and this is 5x, so there is no correlation here. 17 I will bring down later. Let's see what we can do. Now what do I multiply this whole thing to get a 9x squared? So I have to multiply it by 9x. So 9x into x will give me 9x squared. 9x into minus 3 will give me minus 27x. Let's see what is happening here. These two done. 5x plus 27x. See again, the one that you're trying to subtract, whatever the sign of that guy, I'm flipping it, okay? If there is no sign, that means plus sign. It will become minus, and this minus sign will become plus when you're subtracting it. I hope you guys are aware of it, right? Let me know if you see that I'm doing something which is not easy to digest. Okay? So, and this became 5x plus 27x is 32x. And then this minus 17 is the ignored guy so far. Let's bring that guy also down here. Now I have x. What do I multiply x minus 3 with to get 32x? This is simple. I have to multiply by 32. So that is how it got me 32x. Minus 32 into 3 is minus 96. This is minus, this minus will change to plus. These two gone. 96 plus minus 17. That is, check it one more time. I'm not trying to match it with this guy. 96 minus 17. 6 minus 7, 9. 8 minus 1 is 7. 6 minus 7, 9, because I borrowed 1, it became 8. 8 minus 1, 7. 79. See, this is the remainder that we forecasted with help of the polynomial remainder theorem. And that can be believed now because we have seen so many examples of it. Does it make sense or it does not? Does it make sense to Ipsa? See, when you are on video, Ipsa did not have to say a single word. He just showed me a thumbs up. And that was enough for me to be convinced. Okay. So again, I don't want to force you guys to be on video, but if you keep a video on, it's a better channel for communicating with you guys, okay? It becomes easy for me to interact with you all, okay? Alright. So, now, I want you guys to just grapple with one problem, and again, before I move further on this one, I will also show you guys why and how this polynomial remainder theorem came into existence. How we can even prove that polynomial remainder theorem, whatever it says, is a true thing to believe. I mean, you have seen enough example of it, but we'll see the theory part of it also. If I say, I have a polynomial in the form of a function which is x squared, let's say 3x squared plus 15. Okay. If I divide that by x minus 2, what will be my remainder? Can you guys find out real quick? I'm dividing this by x minus 2. What will be my remainder if I divide this polynomial by x minus 2? You will have to apply polynomial remainder theorem. Let's see how much of it you guys have understood, and based on that I will take it forward. So I'm giving you guys 2-3 minutes to deal with it, and then I'll come back. Okay, everybody got the question right? Vasundhara, Riyahi, Sanjita, Bhavish. Okay. Anika, you got the question, beta? Disali, Sana, everybody?
Yes, sir.
Okay. So I'm assuming everybody is giving it a try, okay? Right or wrong doesn't matter, okay? Give it a try. Yeah, Disali, what did you get?
I think I got 27, sir.
27? Okay,
Yeah.
we'll see. Let's see what your friends say. Okay, yes, Bhavesh. You also got 27? Okay, we'll give 2 more minutes to all the other friends and see how it is different from what you guys got, or if everybody is on the same page. But for Dishali and Bhavish, I hope you understood what this theorem says, right? And you had no difficulty in applying it. Okay, let's give it a minute, and then I'll start. Yes, Sanjita.
I got 27.
You also got 27. Okay. With the level of confidence with which you guys are answering, it makes me believe that you guys have understood. Let's see what happens. Yes, Ipsha, what is that you got?
I got 27.
You also got 27. Okay. Okay. Vasundhara, Anika, Sana, what did you guys get? Aryahi. Datta. How about you, beta?
I'm not sure how to do this.
I'm sorry?
I'm not sure how to do this.
Okay. I will come back to it. How about Sana, beta? What did you get? Sana and Vasundhara?
I'm still doing it.
Okay. So I'm giving you guys maybe a minute more. Then I will come back to it. Ipsa, you're saying something, beta? Your hands are raised. Alright. How about Vasundhara? Vasundhara and Anika, I'm waiting for your answers too. What happened, Vasundhara? Upset with me? Not answering me?
I'm still solving it.
Still solving it? Okay, not a problem. How about Anika? I hope none of the kids are angry with me, right? Because I took test yesterday for some of you. Okay. All right. So let's, just in the interest of time, because I have some interesting things in the packet for today. That's why, I mean, it doesn't mean that other days we don't have interesting stuff to talk, but yeah, this one, it's little magical in it, right? I mean, you guys would have seen that now. Somebody says, okay, here's a pack of cards. Pick up a card, I'll tell you without looking at it which card did you pick, right? And that's the magic. Here's the mathematical magic. You can randomly pick any polynomial. Trust me, you can say you pick any power of the polynomial, and if somebody really gets super excited and say, okay, x to the power 297 minus x to the power 15 plus 18, and you will say, okay, if you divide that by x minus 2, or let's say divide that by x minus 1, because our calculation will be easier. You will say that, okay, if you divide this by x minus 1, I will tell you the remainder of this whole division. People will think, oh, how about this? This is such a big deal. You will say, you know what? When you divide this whole thing by x minus 1, your remainder would be equal to 1 minus 1 plus 18, meaning 18. Yeah? And this is exactly what polynomial remainder theorem says. So that's just for you to recap. Okay? Polynomial remainder theorem says that if you have a function as a polynomial, and if you divide that by x minus a, here the a is 2, okay? If you divide any polynomial by x minus a, then the remainder of that division would be equal to f of a. Any polynomial, see how wide this range could be. Any polynomial, you can apply to this polynomial, you can apply it to this polynomial, or any polynomial. Randomly, you can assume any polynomial, and if you divide that by, let's say, x minus 4, the remainder of that would be equal to f of 4. Any polynomial divided by x minus a will have a remainder of f of a. That's what this polynomial remainder theorem says. Yeah? So, when I gave you guys this question, that if you divide by this, what will be the remainder? And most of you said 27. I believe Sana and Vasundhara are also close to being done. How about Ariyahi? Ariyahi did not tell me the answer. What did you get, beta?
I was still solving what you did.
Okay. So here's the thing. Now you guys can solve along with me. I'm trying to divide this polynomial by x minus 2. And we're trying to find out what will be my remainder. The polynomial, we can always say, okay, fine. I will divide this by x minus 2 and find out the remainder. If you are clear about the polynomial remainder theorem, you will not do all that. You will say my remainder would be equal to f of whatever is getting deducted from or subtracted from x. So it will be equal to f of 2. Let me plug the value of x equal to 2, evaluate this for 2 and see what my remainder would be. It will be 3 into 2 to the power 2 plus 15. So 3 into 2 to the power 2 is 4 plus 15. This is 12 plus 15, which is 17. So this was an easier calculation. I know this puts an extra burden on our head to know and remember one more theorem. If you remember this theorem, that is wonderful. If you don't, you can always do the long division to find it out. Okay? Yeah? So Sana, Anika, Sundra, yes, Datta.
Sir, wouldn't it be 27 because it's 12 plus 15?
Now you know how does anybody make a mistake by due to an oversight. Yeah, but yeah. See, good thing is, I could figure out, or you could figure out where the problem is. You did not tell me that, sir, you are making it wrong. You said that wouldn't it be 27 because you are adding 12 plus 15. So this is another thing that I keep insisting on. When you are solving a problem, do it step by step so that you will be able to figure out where you went wrong. And we all go wrong, okay? If your teacher can go wrong, students can go wrong as well. And we are all human beings, right? We make mistakes, okay? But yeah, get into the habit of doing it step by step. That will help you decode where you went wrong, and that will help you with the review process also. But thank you so much, Atta, for pointing it out. So is everybody clear about it now? Aryahis, Anika, everybody clear? Now let me add some interesting flavor to it. We are just not here to apply it and get it. You will see some interesting problems which will look very complex in the first go, but when you decode it or relate it with the polynomial remainder theorem, you will be able to figure it out. Let's see. Let's look at this problem. I will let you guys struggle with this problem for a little bit, okay? And then I'll show you how simple it is, so that I can get extra credit, right? This is a polynomial graph. So again, I did not do a great job with drawing of it, but what I did was I tried matching the numbers so that you can relate to it. Okay? Now, this graph is coming from, it's a polynomial graph. So you had a polynomial function y equals f of x, and that was into some polynomial which plotted this for us. Okay? Now the question says, what is the remainder? What is the remainder when p of x is divided by x plus 2? There is no polynomial function given to us. We just have a graph in front of us. With this question, this says this is the graph, this is a polynomial graph, whatever function you have, there is no description of the function, it doesn't say it's x squared plus something or is it x cubed plus something or whatever. Okay? You just have polynomial graph, and the question says, what is the remainder when p of x is divided by x plus 2? Now, what is the remainder when p of x is divided by x plus 2? And I want you guys to literally think about it for a minute or two. Did everybody hear the question clearly?
Can you please repeat it?
Yeah. I'm reading the question one more time. This is the graph that you guys can see, and the peak of this graph is at 1, as you can see here, and it touches the x-axis at 2. Okay? On this side, this is between 0 and 1, this crosses the x-axis, and the peak again is at minus 4. Y equal to minus 4. And it meets the x-axis again at in between 2 and 3. This is the pictorial part of it. The question says, what is the remainder when P of x, so this is not f of x, this is polynomial P of x, okay? So that's how you will read it. Polynomial P of x. So y equal to P of x, okay? This is your y, this is your x, and this is plotting the polynomial P of x, okay? It says, what is the remainder when P of x is divided by x plus 2? Okay? And from this information, you have to go for a treasure hunt and think about it. I'll give you guys maybe 2 or 3 minutes to think about it, okay? This problem will look very scary to begin with. But when you decode this into pieces, it might become easier. I'll give you guys 2 minutes to think, okay? I mean, I can solve it in 30 seconds, but I'm not doing it. I want you guys to think. Let me just draw it a little bit better so that it makes sense. So just for you guys to know, the peak, this side, the bottom of this graph is at x equal to minus 2 and y equal to minus 4. Just so that you can see it clearly. Sana, what's going in your mind, beta? Tell me. Are you able to think about something?
It's really confusing.
Okay. How about Bhavish? You heard the question, right? I'm reading the question one last time for you guys, okay? This is the graph that you have here, and there's no description of the function given. It says this polynomial P is graphed. This is polynomial P is graphed here. It says, what is the remainder when P of x is divided by x plus 2? What is the remainder when P of x, whatever is the P of x, which is graphing this, when you divide that by x plus 2, what is the remainder? Okay? Datta, how about you, Datta? Is it haunting everybody?
Yes.
Kind of, okay. So, alright, how about Vasundhara? Vasundhara, Samrita, what's going in your mind right now? Lisa, what are you thinking about right now?
So, I noticed that on the x-axis, see like it reaches 2,
Uh-huh.
and I think the y is like 4.
Uh-huh. Minus 4.
Yeah, minus 4.
Mm-hmm.
So, I noticed that, but I messed up on everything else.
Uh-huh. Okay, so now let me try decoding this for you guys. And are you guys with me so far? I mean, is everybody paying attention to my magical words? Ariyahi, Sundara, Anika, everybody? Okay. Now, so let me read this question. This question says, the polynomial P is graphed, y equal to P of x. That's what you are seeing here. And I'm just noticing it, that okay, at x equal to 1, it has a peak, x equal to 2, it meets the x-axis, meaning the y value becomes 0. If I go on this side, it is crossing x-axis between 0 and 1, and at x equal to minus 1, I mean 0 and minus 1, sorry. And x equal to minus 2, it reaches its peak here, which is equal to y as minus 4. This is the observation. Now I'm reading the question. The question says, what is the remainder when p of x is divided by x plus 2? When this function is divided by x plus 2. Now if you guys recall the theorem, the magical theorem that we learned today, which is called polynomial remainder theorem. It says this is a polynomial graph and it's asking for remainder. So the first thing that we will try relating to would be polynomial remainder theorem. What does the polynomial remainder theorem say? It says if you have a polynomial, anything, and if you divide that by x minus a, then your remainder would be equal to p of a. Here this guy says what will be the remainder when p of x is divided by x plus 2. So it's not divided by x minus a, it's divided by x plus 2. Our a is a number that is getting subtracted from x and it's asking about x plus 2. That means I am subtracting minus 2 from x, correct? And whenever I divide a polynomial by x minus a, here my a is minus 2, my remainder is equal to p of a. So when I am subtracting minus 2 from x, my polynomial will be equal to p of minus 2. Meaning, what will be the value of y, p of minus 2, meaning value of y, when x equal to minus 2. When x is minus 2, my y is minus 4. That is what it is asking for. It's saying that you have a polynomial and it did not give any description, it did not give you a breakdown of how that polynomial is constructed. It's just asking you, when you divide this polynomial by x plus 2, what will be the remainder? Without the description of the polynomial, just by looking at the graph, you could make out, oh, this is a polynomial getting divided and we have to find the remainder. So we have to apply the polynomial remainder theorem. What does it say? When you divide a polynomial by x minus a, your remainder would be equal to p of a, function of a. I mean, you will evaluate this for a. What is my a here? Minus 2. So, meaning, what will be my value for p of a? That will be my remainder. So, meaning when I give the input as minus 2, what is my output? Minus 4. Does it make sense? Kind of? Datta? Sanvita? No? Datta, it makes sense. Datta. How about Sana? Sundara? Okay. Aryahi. How about you, Beta? Bhavish? Yes, Bhavish.
Well, I didn't rate mine. I didn't mean to rate mine.
But did it make sense or not?
It made, I got confused at the beginning, but it makes somewhat sense now.
Okay. So I'll just repeat one more time, okay? So I must praise Ifsha for being the odd one out here. She's all alone on video. It's only she being on the video, but that gives me the comfort, okay? Thank you, Beta, for being the odd one out. But without you saying anything, you said, okay. That was good enough indication for me to repeat it one more time. So the question says, this is the graph of the polynomial. What it is asking is, it's saying that what is the remainder of this polynomial when it is divided by x plus 2. So we have three words that we are catching: polynomial, remainder, and divided by something. That is exactly what the polynomial remainder theorem says. It says that when you have a polynomial, f of x or p of x or g of x, whatever it is, and you divide that by x minus a, your remainder is equal to f of a. Here, this is a polynomial, we are dividing by x plus 2. meaning I'm not having, my a is nothing but minus 2. Okay. So my remainder would be equal to f of a, f of minus 2, or here it is p. So my remainder would be equal to p of minus 2. Okay. So basically, whatever is the output for whenever I evaluate this polynomial for minus 2, that is what would be my remainder. And in this polynomial, when my input is minus 2, my output is minus 4. This is my value of y. So basically, when I am evaluating this for my value of minus 2, my y value is minus 4. That is what will be my remainder. Does it make sense now? If so, it is slightly better. Okay, how about Vasundhara, Sanjita? Okay. How about Anika, Aryahi? Everybody okay? Alright. So let's see if we have any other problem that we want to deal with. Because see, these are, I know I keep talking about stories, but this is one of the another story. Okay. Any concept of math is like a ghost. You'll be scared of it till you don't see it, till you don't deal with it, till you don't try to scare it back. So any concept that you come across, anything that you learn, make sure that you are practicing some of it, and that is when it will become easy. That fear, that scare will go away. So let's see the ghost one more time. Now the next question, or the last question for the class. P of x is a polynomial here. Here are few values of p of x. It says p of x is the polynomial. Okay. Here are the few values of p of x, and we have some values given. P of minus 2 equal to 1. P of minus 1 equal to 3. P of 1 equal to 0. P of 2 equal to 4. So this is a polynomial, we have some values given for it. Basically, this polynomial is evaluated for the value of minus 2, minus 1, 1 and 2 and the other outcomes. So far okay everybody? Now the next part of the question. So it has two parts. What is the remainder when p of x, okay, so let me write it here. What is the remainder when, first scenario, when px is divided by x minus 1, and second question is, this is the first question. Second question is, what is the remainder when px is divided by x plus 2? Okay? So I'm reading the question one last time and I will let you deal with the ghost. Px is a polynomial. Here are few values of p of x. So p of minus 2 equal to 1, p of minus 1 equal to 3, p of 1 equal to 0 and p of 2 equal to 4. These are the four values for which this polynomial is evaluated and the values are given here. So now we have to answer these two questions. First question, in both the cases we have to find out the remainder. In the first case, px is divided by x minus 1. What is the remainder? When px is divided by x plus 2, what is the remainder? And I will let you guys do whatever you want to do to get rid of the ghost. If I did a decent job of explaining this concept to you guys and you could process this file, you should be able to solve this in 30 seconds. Maybe 2 minutes. Okay, I will let you guys use next 2 minutes of your life in a more productive way. I hope everybody is trying, right? Dishali, Sarvita, Vasundhara, everybody, right? Yes, Dishali.
Wait, are the options at the top, are those the options?
I don't know. I will read the question one more time. See again, I know you are thinking the right direction, but I don't want to be explicit. Okay? I'll read the question one more time. Because that is the trick that we use. That's what Rand says. Read, analyze, and then do it. So the question says, Px is a polynomial and these are the values given. For different values, these are the values for which this Px or the polynomial is evaluated. When P of minus 2 is equal to 1, P of minus 1 is equal to 3, P of 1 is equal to 0, and P of 2 is equal to 4. These are the four values for which this polynomial is evaluated. So I would not term them as options, but there is a lot coming from there. Does it make sense, Duda?
Yeah.
Okay.
So I have to answer the questions?
Yes, please.
Okay.
Datta, what's going in your mind right now?
I think I solved.
So, see, when you guys have solved it, why you guys are doubting yourself? I want you guys to be 10 times more confident than me. Yes, Sana. Yes, Sana, tell me, what do you want to share?
For like the first one, if I got like P of -1, do I just say the answer is 3?
Yeah, I mean, you just have to tell the answer because the question, when you are in the exam, you will only tell the answer. Yeah, it says what is the remainder when px is divided by x minus 1. So you have to tell me, okay, my remainder is 3 or 4, whatever it is. Tell me what are the options you have better. First and second one. Sana?
I don't know. For the first one, I got 3. I didn't solve the second one.
Okay. Let's go to Dishali. Dishali, tell me, what did you get?
For the first one, I got 3, and the second one, I got 4.
One more time. How much?
4.
4. Okay. So this is 3, this is 4. Let's see. What did you get, Savita?
For the first one, I got 0, and for the second one, I got 1.
Wonderful. I love it. I want to see the unity in diversity. Yes, Datta, what did you get?
For the first one, I got 0, and the second one, I got 4.
Okay. Interesting. Sana?
I want to change my answer.
Okay.
For the first one, I got 0, and for the second one, I got 1.
Okay. How about Bhavish?
No, for the second one, I got 4.
Okay, second one you got
First
4.
one I got 0, second one I did 4.
Okay. How about Vasundhara? Vasundhara, not upset with me, right? You're not saying anything. How about Anika? Ipsa? Ipsa, how about you, brother?
I got 0 for the first one, and for the second one, I got 4.
Okay, how about Aryahi? Yeah, Vasundhara, tell me, brother.
I got 0 and 1.
0 and 1. How about Datta?
The second one's actually supposed to be 1.
Okay. How about Aryahi?
I got 0 and 1.
Okay, what is Shali?
For the first one, I'll change my answer to 0.
Okay. Second one is
4.
4. Okay. Now, whatever I preach is what I will practice. Let me change my hat to become a student for 2 minutes and solve it. This is the polynomial, and we are given these values. So p of minus 2 is 1, p of minus 1 is 3, p of 1 is 0, p of 2 is 4. Okay. So when I read this, to me it seems like this polynomial is evaluated for minus 2 and the value is 1. This is evaluated for minus 1, the value is 3. Evaluated for 1, value is 0. Evaluated for 2, value is 4. Now it says, what is the remainder when p of x is divided by x minus 1? What is the remainder when p of x is divided by x plus 2? Now, this is a classic case of polynomial remainder theorem that we can use for solving this problem without much of a trouble. But the polynomial remainder theorem says that if you divide a polynomial, since this is saying p of x, I will talk in terms of p of x. It says when you divide a polynomial by x minus a, your remainder would be equal to p of a. That's it. Now, when I'm dividing by x minus 1, that means my a is equal to 1. So my remainder would be equal to p of 1. Oh, do I know the value of p of 1? P of 1 is 0. Okay. When I'm dividing this by x minus 1, my value will be p of 1. P of 1 is 0. So 0 is the answer that I will get for this one. Same thing, when I divide this, px is divided by x plus 2. So my a is equal to minus 2. Because it's always in the form of x minus a. So you have to think on those lines. That means when I am dividing this by x plus 2, my a is minus 2. So my remainder would be equal to p of minus 2. Do I know what is the value of p of minus 2? P of minus 2 is 1. So it will be 1. Was that simple and sweet? Ananya, you joined just now, so I'm pretty sure you would have not followed much.
The past 30 minutes.
Oh, you were there in the class for the last 30 minutes. Okay, I did not notice it better. I was so very lost. But I hope you are following it, right?
Yeah.
Okay. So this was an example of, we were trying to solve this problem. And again, if you look at it, this whole, any problem of this nature, the previous graph that we were trying to solve for versus this problem, it was all boiling down to we knowing one simple concept which is polynomial remainder theorem. It says if you are dealing with a polynomial and you have to find out the remainder. So keep these two words in your mind, polynomial and remainder. If you are coming across this, the first thing that should come to your mind is, okay, it's talking about polynomial remainder theorem. Do I recall what exactly it is? It is very simple. If you have a polynomial, if you are dividing that by x minus a, your remainder will be equal to p of a. Okay? So basically you have to evaluate your polynomial for the value of a, which is getting subtracted from x, and that is what will be a remainder. Okay? So here in this case, when you are dividing it by x minus 1, that means your a is 1. So you evaluate this for p of 1. P of 1 is here, 0, done deal. When you are dividing this by x plus 2, meaning your a is minus 2. So you will evaluate this for p of minus 2. Do you have the value for that? Yes. That is what it will be. So if this polynomial remainder theorem becomes a concept for you all to relate to, solving this kind of problem would just be a matter of few seconds, not minutes. Yep. Everybody can leave. We are done with the day. Don't worry about it. Yeah. But is everybody clear and comfortable about it?
Yep.
Okay?
Yes, sir.
Sanvita, Vasundhara, Sana, Disali, Anika, everybody okay?
Yes, sir.
Then no point wasting any further time with me. Okay? See you guys in the next class. Have fun.
Thanks.
Alright. Bye bye. Bye bye.